quadratic word problems. Okay? We're going to be taking the properties of quadratics to solve real-world situations. Okay? We know how to find the vertex of a quadratic, right? What's the formula we use? To find the vertex of a quadratic, what's the formula we use? Yes, louder. Negative b over 2a. That tells us the x-coordinate of our vertex. How do we find the y-coordinate? How do you find the y-coordinate? How do you find the y-coordinate of any point? You take the x value and do what to it? You plug it in. So to find the y-coordinate of your vertex, you take the x-coordinate and you plug it in to find the y-coordinate. Okay? How do we find the x-intercepts? Say again? Quadratic formula. To do these application word problems, you're going to be doing one of those three things. Finding the x-coordinate of the vertex, finding the y-coordinate of the vertex, or finding the x-intercepts. It's going to be one of those three. Okay? So your goal is to read the question and to determine which one of those three things are you looking for. Okay? Because you're going to be given the equation every time. It's just a matter of which one of those three. Okay? So the number, you can read it. Okay? You have the equation right there. This right here basically tells you the restrictions of your temperature of your food. It's either going to be between -2 and 14. Your answers, okay? At what temperature will the number of bacteria be a minimal? Minimal. Sounds like what other word? Minimum. And a minimum is associated with what concept from quadratics? Max and min, aka the what? Not the A. What's that middle point called? Vertex. Yes. If it's talking about a minimum, you're looking for the vertex. Now, what part of the vertex? Are you looking for the x value? Are you looking for the y value? The y. So here, at what temperature will it be the minimal? You're looking for the y coordinate of the vertex. So that's what you have to find for this problem. Anytime it talks about what's the minimum, maximum, minimal, the highest it could go, the lowest it could go, it's asking for the y coordinate of the vertex. Okay? And how do you find the y coordinate of the vertex again? What x? Gotta be careful. It isn't the coordinate, but it's the one that you get when you do what formula? Negative b over 2a. So you have to do negative b over 2a and take that value and plug it into the original equation. Okay? So, what's b? So you got to take 1/2 and plug it in for t into your equation to get your answer. Okay? Do that now. So you get 20 times 1/4, order of operations, minus what's half of 20? 10 plus 120. 20 times 1/4 is 5. 5 minus 10 is -5. Plus 120 is 115. So that's how many bacteria you're going to have the minimal amount of bacteria that's going to be, in this food. Okay? Understand? So identify what the question is asking. Which one of the three things is it? Okay? Let's look at the second one. Read it. So you have your equation, and it asks two things here. Find the time it takes for the object to strike the ground. What do you think that's going to be? X-intercepts. This right here, does this quadratic open up or down? Down. So this basically looks like this. You have an object. That's the path of it. So where does it hit the ground? Okay. Here, where it starts, and then here again. Okay. So yes, to find the time it takes for the object to strike the ground, they're looking for the x-intercepts. And how do you find the x-intercepts? Quadratic formula. Okay? I want you guys to take this equation, plug it into the quadratic formula, and get my two values. Okay? Do that now. Right? You plugged it in? Now, yes, 256 is not a perfect square. Okay? But it's asking us the time it takes for the object to strike the ground. We do need to go through with this. So yes, we're going to get some decimals. Okay? We're going to get two answers. What we get when we add the square root of 16,256 divided by negative 32, and when we subtract. So you need to type these in and get that decimal approximation. Okay? So, yes, ma'am.
Because I get negative and a negative.
Which makes a positive.
Yeah. We add them together, right?
Yes. Is that not what it's asking? Ooh. Okay. I saw some people got 16,256. What about everybody else? Okay, so we got some different numbers. Okay. 64 squared is what? A negative and a negative make a what? Positive. What's 4 times 16 times 190? 160. When I add those together, what's that number? It's what? It is 16,256? Okay. Just want to make sure. Okay. So are we typing this in? Are we getting our number? The first one, did you get a negative 1.98? For this one, did you get 5.98? You're going to have to do the entire top part, enter, divided by negative 32. Now, these represent my x-intercepts, but in context of the problem, what do they represent? The time. Can I have a negative time? No. So when it asks you, find the time it takes for the object to strike the ground, I can't consider this right here because it's negative. So that means I'm starting at a time of 0. And I go all the way to 5.98. So that's my answer. It's going to take almost 6 seconds for the ball or the object to strike the ground. And you use the quadratic formula because it's asking for basically the x-intercept. The x-axis represents the ground. Now, there's a second part to it. It's asking us to find the maximum height of the object. What does that mean? Of the vertex. I'm looking to find the maximum height. That's the y coordinate of the vertex, just like the last one. So this part right here is just like what we did for the last problem. So we have to find the x coordinate of the vertex and then do what to it? Plug it in. So I want you guys to do that. Find the x coordinate of the vertex and then plug it into the function. Okay, so we got to find the x coordinate of our vertex and then plug that in to get the y coordinate. That's negative b over 2a. What is it? Which is? Now, if it asked you, how long does it take to reach the maximum? That would have been your answer. Because this is the x coordinate, aka the time it takes for you to reach that maximum height. Okay? So 2 represents the time it takes to reach the maximum height. But we're concerned about what is the maximum height. Okay? So we got to take that and we got to plug it in. What you get? So that's how high it goes on your graph. Okay? That's how high the object goes. Okay? Questions? Read it. What is it asking for? How long will it take to hit the ground? AKA X what? X-intercepts. Which means we have to use what? Quadratic formula. Okay? Told you it's going to be one of those 3 things. Okay? Quadratic formula because it's asking you for your x-intercepts. The maximum height, minimum time, y coordinate of the vertex, or how long it takes to reach the maximum. Okay? Do the quadratic formula. Oh, our equation's halfway missing, isn't it? Okay. Now it says a ball is thrown upward from a height of 15 feet. So that's where it starts, 15. That's not your, it's your y-intercept. Okay? It says it's thrown from 15 feet. That's your y-intercept. And if you think about standard form, what part of standard form represents your y-intercept? The C. So in this equation, which one of these represents C? S. So right now, so far we have this. Then it says the initial velocity of 5 feet per second. That 5 is going to go in for what? V. So there's your equation, right? Give me the quadratic formula and the solutions for this. What was the discriminant? 985. So what did you get when you subtracted them? When it was subtraction. Square root. If it's a minus, you make it a negative, and then subtract 5. Huh? 1.14. What about when you added? But there was a number after the 3 that would have rounded up 3 significant figures. Point what? Can I have a negative time? So how long did it take? 1.4 and doesn't say how long. Okay, we'll just leave it like that. I want to do the last one really quickly because there's one like it on your homework, okay? But it's still one of the 3. Quadratic formula, x coordinate of the vertex, y coordinate of the vertex. If a toy rocket is launched vertically upward from the ground level, then its height after t seconds is given by the equation. That represents the height of this toy rocket at any point in time. It says after how many seconds will the rocket be at 112 feet? 112 feet, does that represent a time or a height? It represents a height. So that means since h of t represents the height of the rocket, I can plug 112 in for h of t. And then it's asking me how many seconds. That means I'm looking for the what? The time. And how do I solve this? I need to subtract 112 over, and this is nothing but another quadratic where I use what to solve? Oh, yeah, we could use completed square, but quadratic formula to solve this. Okay? And then it would tell me the time the rocket will be 112 feet. Okay? Now, I just wanted to start that one off. I will do the video. So, as you can see, your 2 solutions are 7 and 1. Both of them are real. So that means that it's going to take 1 second for the rocket to reach 112 feet and then 7 seconds as well. Okay? The reason why is because when your rocket is making its path 112 feet, it's here. So there's going to be 2 places where the rocket is going to be at 112 when it's going up and when it's coming back down. So that's why you have those 2 answers. And yes, both of them are your answers. 1 second and 7 seconds.